Master System is a 3D printable modular photoprocessor, modular 4x5 camera system, and 4x5 roll paperback, which takes a cassette of 4-inch wide roll paper, a brand new analog format. All of the files for the Master System are for sale at CAMERADACTYL.com. The processor can be configured for black and white prints or negatives, C41 color negatives, RA4 prints, or rolls of 4x5 RA4 reversal positives shot in the roll paperback. In this video, I'll assemble all of the processor modules and set them up to process 35mm black and white film and do a little processor maintenance at the end of the video. I'm uploading the slicing and printing instructions as a separate video, so if you've already downloaded the files, I'd suggest you actually watch this video once through and then go watch the printing instructions, print it all out, and then come back here and assemble and pause along with me. In future videos, I'll set up a processor for C41 film and RA4 color positives, and I'll make the assembly videos like this one for the camera system and the roll paperback. Here's what's going on in the rest of this video. Slicing and printing instructions are in a separate video, so I'm going to get right to tools and hardware, then assembly of all of the modules. First the processor unit, then the motor mount, then the roll feed, then the pump hanger, then the 4-inch roll paper cassette itself. After that, I'll set up the processor for black and white film, do some processor maintenance and upkeep. Enjoy! The tools. M3 hex key driver. Teeny tiny hex driver for the wheel hub that attaches the motor to the drive shaft. Wire cutter, pliers, or a Leatherman. Eventually I cheated and used a wire stripper. I used a soldering iron, a heat gun, an X-Acto knife, one of these little screwdrivers, a helping hands, universal processor wrench, and this hot melt glue gun. I used Weld-On 3 and a squeeze bottle plasticator applicator with 23 gauge pre-bent blunt tip lure lock tips, and gloves. Materials. For each processor unit, you'll need one 3/8 by 16 1-inch 3/16 stainless bolts. You need two 2.5-inch versions of the same thing. You'll need 7 150mm long 3mm in diameter stainless steel rods, 304 stainless or higher. You'll need 12 4.5 ounce 9.5mm medium Siberian Tiger dental elastics, 18 inches or 450mm of 3mm internal diameter by 5mm external diameter silicon tubing. This is going to be for the circulation pump of each unit. You'll need about 1 foot or 300mm, maybe only 250, of black silicon tubing, 7mm ID, 9mm OD. This is for your overflow ports. I like to mark my engineering reference kits that I use for building prototypes with what I am using. Each processor unit needs one 10mm ID, 1.5mm in section metric O-ring. You need about 18 inches or 450mm of 1-inch 3:1 heat shrink tubing, rubberized. That's all the hardware that you need for one processor unit. This is what you need to build the roll feeder. 10 M3 by 16 socket head cap screws. These are driven with a 2.5mm hex key. 2 10mm M3 cap screws. 2 3/8 by 5/8 inch springs. And 1 7/32 by 11/16 spring. Weld-On 3 plasticator gloves, applicator tip. Alright, this is to build the motor unit. One of these motors. I'm using a 5 RPM version, but This is a 20 RPM version, just purposes 5 RPMs. This motor, this bolt pattern, I'll put the bolt pattern up on the screen as a drafting or motor spec. About 3 feet of speaker wire, 2 wire nuts, 2 XT60 pigtails, both female. This is a male and a female here. You can also get these end connectors and wire them up yourself. I show you in the video. These are 5.1 millimeter barrel jacks. You just need one of these. You need about 1/4 of a glue stick. You need 5 16 millimeter M3 cap screws, and you need 1 10 millimeter M3 cap screw. And you need a 12 volt power supply. And 2 of these PWM controllers. Each unit that gets circulation gets one of these peristaltic pumps. Each pump unit will get 2 to 4 male hose barbs, 4 to 8 M3 hex cap screws, 16 millimeter, 1 male and 1 female XT60 pigtail. This is the cassette. It only requires 1 non-printed component. It is this spring. 0.4 millimeter wire thickness, 5 millimeter in diameter, and 25 millimeter long. You can also get a 30 in there and it'll work just fine. Alright, here are the instructions for all the sub-assemblies for the photoprocessor. We're going to do the rubber-coated inner rollers first. Slip about a 6-inch piece of 1-inch diameter, 3:1 shrinking rubberized shrink wrap over one of these rollers. Now it's important you print the rollers out of carbon fiber filled PETG on strength mode. I'm going to reiterate that, although that's in the slicing instructions. You're going to try and use a hot heat gun really fast to heat up the shrink wrap really quickly without it transferring too much heat to the roller, causing any warping. This should be pretty easy to do in carbon fiber PETG with a regular heat gun. Shrink the shrink wrap past the end of the roller and then use some scrap, something flat, to roll out any bubbles. I like to rotate the roller then and hold a sharp X-Acto knife against the end to try and cut a really clean circle and pull off the top of the shrink wrap tubing. Next we'll assemble one processor unit. Take 2 6 to 9 inch sections of 3 millimeter by 5 millimeter ID by OD silicon tubing. Put one of those hoses through the hole in the tub frame. Route the other hose down through the lower slot in the tub frame. Put the tub frame in the tub with the silicon tubing and light baffle component on the same side as the overflow hole. Make sure that the 2 silicon tubes aren't pinched and that they're running through their channel to the lip of the tub. Pull the tube so that about 1 inch sticks through into the tub on both tubes. Next we'll install the overflow nipple. There's the nipple, the jam nut, and the O-ring. First place the O-ring at the base of the nipple. Slide the nipple through the tank overflow port. Then add the jam nut with the flat surface towards the tank. Add a 1/4 inch ID by 3/8 inch OD black silicon tube to the overflow nipple. Okay, put these paper slide guides into the bottom of the tub frame. They slide in left and right. They are not interchangeable. They redirect the paper from the second roller set to the third at the bottom of the tank. Next, you're going to want to grab the circulation flute. This has one side with 1/4 pizza cut out and all of the jet holes for circulation. Anyway, those are going to be facing you if the overflow ports are on your left. Then it sort of just clicks into place. And I think that means we're done with the tub. We can put that aside and move on to the cluster. Grab 6 roller pivots and stick them into their slots in the bottom of the roller cluster. The internal pivots do not move, and the outer pivots slide back and forth along their axis. Take 6 steel rods and put them into each of the roller pivots. Now, first take the coated inner rollers and slide those along the inner roller pivot rods. Then the outer rollers on the outer roller pivot rods. Then 6 more roller pivots on top of each rod. And now let's talk about the drive shaft. We're going to put a little bit of crayon on the bearing surfaces of the drive shaft. There are 2 pillow blocks. They are not identical. Figure out which way they go. The drive shaft should be centered in either of them with a little bit of non-spline sticking out on both sides. Slide the pillow blocks into the cluster. Take the sun gear and put the sun gear in its place, propping the cluster up so that you don't drop the bottom and push all of the pivots out of their holes. Okay, we're going to use a rod here to push against the faces of the roller pivots to align them so that we can put the roller cluster face on top. So watch, I'm going to demonstrate this here. Yep, you see how those align? We're going to do that while we're putting the face on. So we're going to start with just getting the round pin heads of the roller pivots in their slots like that. Rub another steel rod against their edges until they align, allowing the cluster face to drop into place. I might have to squeeze the pillow blocks into place because those fit into pockets in the inside of the cluster face as well. There's a universal processor and camera wrench for those bolts that you can print out if you don't have a normal socket set, and I actually find them useful. I put one in every pencil cup. Anyway, you're going to tighten all of these bolts about finger tight so your cluster is in one piece, and then make sure your drive shaft spins. Next, you're going to need 12 4.5 ounce medium 9.5 millimeter dental orthodontic rubber bands for braces. You need 2 rubber bands on each pair of roller pivots. That's 4 rubber bands per pair of rollers. Check your springnicity, that all of your rollers are moving nice and smooth and parallel. You should now be able to check that you can run a piece of paper through the cluster. Normally it would hit the slot on the bottom of the tank, so you'll have to push between roller pair 2 and 3 to check it at this stage. Then you can pop it back into the tub.
For this episode of In an Instant.
The kind of photography that would become part of the human being. Press a button.
I have glued every one of these in my shop and on the internet. Ooh, did it come apart? Okay, here is how the dryer lid goes together. First, you're going to take this frame. Okay, so you're going to take this frame. It has an open hole right here and a dead end hole right here. You're going to slide one 150 millimeter long 3 millimeter rod through. Then we're going to put the dryer exit roller on and just slide it through into this hole down here. There we go. The next part, we're going to take this ramp baffle and stick it over here. The part should stick through here. Let's see if I can get it through. There we go. It should stick through to the face and a line over here. This component is not double-sided. The short space end is on this side. Oops. Pop that together like that. A drop of cyanoacrylate glue, that's crazy glue, will hold all of this together. Weldon 3 does not bond PETG so well. Hey, can you notice that before when I did wire nuts, I was actually just using 2 of these put a couple of drops of glue on it. This can fit right into this slot, just like the light baffles do on the regular lids. Boop. And you can put a couple of drops of glue right there, and there you have the dryer lid. Okay, on the input lid with the hole for the motor and the roll feeder, there are two triangles right here and here. You can better see them on this side. They just push in and they get a drop of weld-on 3. Now let's assemble a motor unit. This is the motor housing. This is the motor housing faceplate. This is the motor drive coupler. Here I'm going to solder the red wire, which I'm going to make the positive in this convention, to the back leg. And the front leg will get the black wire. The side leg I'm bending right here just to grab it with my helping hands. See, the side connector is unconnected, black at the front, red at the back. Okay, that sits in the top porthole in the motor housing, just like that. We'll come back and hot glue it later with the other ports. Now we're going to make two XT60 pigtails. These are female XT60 water resistant connectors. In this project, we're going to use the convention. The rounded side gets the red wire, the square side of the plug gets the black wire. So rounded side positive, square negative. You want about 1/4 of an inch of bare wire sticking out. You're going to use your helping hands and solder up a pigtail. Put the back over the wire. There's a black back cap that I slid over the wire before I solder. That way at the end we can fill it with some water resistant hot glue and snap it back together. Okay, we're going to watch me solder a small ball of solder on the tip to transfer heat to the copper wire, and then melt the soldering wire into the copper wire, eventually wicking to the brass terminal. Okay, filling that with hot melt glue and then snapping it together. You can wipe off any excess. You have a fairly water resistant connector. We're going to make 2 of those. Now solder the red to the plus side. It's marked on the back there, the plus side of your motor, and the black to the negative side. Now fill all of these portholes with hot melt glue and press in your connectors. At the top there's the power connector, that's that barrel jack. Then I'm threading 2 female XT60 connectors. I want their rounded side of the ports up. It'll just be a helpful convention later. That's the red wire up when these are seated in a little bit of glue. Okay, next we're going to use 4 M3 by 10 millimeter hex screws to connect the RC car hub to the drive coupler for the motor unit. Then we're going to use 3 M3 by 16 millimeter screws to connect the motor itself to the motor housing. There are 6 holes, you only need 3. Make sure none of them are next to each other. Okay, then what is the logic of all this? So the power port gets 12 volts in. That powers 3 things directly. It powers the input to the 2 PWM controllers, and it powers the lower XT60 connector. That's just a 12 volt out for an accessory such as a full speed circulation pump. The second XT60 connector, the lowest port, is connected to the output of the lower PWM controllers. And that lower of the 2 will then control, let's say, dimmable or slowable circulation controllers for baths that you want a specific circulation in photoprocessing, let's say developer. Then the output of the upper PWM controller is the input to the motor, And it will, of course, control the motor speed and thereby the process speed. We're going to open up all of the ports on all of the PWM controllers. You will use all of them, and you want to make sure that you've got, I don't know, about a 1/4 inch of bare wire sticking out of each wire. There are two 180-degree opposed grub screws in the collar of the RC car wheel hub. Orient one of them against the flat of the D shaft of the motor and tighten it up. Then we're going to plug the thing in and turn the motor 180 degrees. Stop it by pressing the button on the PWM controller or unplugging it, and tighten up that second grub screw. Then you can test your unit out before you pop it all together. You can pop the faceplate on and then stuff those wires in there with a little bit of a loop so that you can wiggle them around. And then you want 1, 2, 3, 4, 5, 6, 5 16 millimeter and 1 12 millimeter M3 hex. All right, you're done. That's a motor drive unit for the CAMERADACTYL Master System modular photoprocessor. You only need one of these, but you can collect all 4. Now let's build one of these pump hangers that allows you to hang one of these pumps along the lip of a 5-gallon bucket. Use 2 screws to screw the pump to the pump hanger with the silicone tubing through the 2 holes. Then put the cone over the back and screw those down. It's that I solder them while they're going through the back cap. They're made in a way such that they dovetail together and fit around the rim of a 5-gallon bucket. Roll, feed, assemble! Alright, these are the components for the roll feeder. This is Weldon 3. It's a solvent. It actually melts the PLA plastic together with itself and then flashes off and dries. Okay, these are the first 3 STLs we're going to start with. The body and then the 2 light seal flange pieces. We're going to put them together like that. Make sure that all of the joints are seated flush. And then just squeeze a little bit of that Weldon 3 in the joint. Let it flow. Through capillary action, it'll wick through all of the joints, melt the plastic together, and flash off in a few minutes. Next, take the back cap, click it into place. And we're going to use some Weldon 3 only from the inside to glue it all together. Weld it all together. While that dries, let's set it aside and then we can take out all of the components for the lid. Here are the components for the lid. Take these out plus this hardware. So to align this knob and this locking cam spline plate on the inside here, what you're going to do, the knob should have the 2 red dots lined up on the face, and then when you turn it over, if this bottom part is on the ground, this rectangular locking spline tooth should be at about 2 o'clock, and that's the counterclockwise limit to its rotation because of those semicircular cams on the back, and they can rotate this way all the way down here, but when this is at 2 o'clock and up against the semicircular cam slot, these 2 are aligned. Aligned like that, I'm going to use these 2 long thin pins just to keep them both in position. And then I'm going to use 3 16mm M3 hex screws, and I'm going to screw this black cam plate to the outer knob. They should be tight to each other and rotate smoothly. Okay, when you've got that all together, you can take the indicator knob and stick that through from the front side. Then put the spline over the tail of it. Use another 16mm M3 screw and screw it together like this. I shot it from all of the angles, none of which I centered correctly, but here, yeah, this is a good one. That's how I did it. You could do it too. And again, everything should spin freely move freely once your lid is done. We can put the lid aside for now. Stick one of these big springs in that lock button hole, and then take the lock button. We're going to make sure it moves in and out. We're going to use a 16mm M3 hex screw diagonally through this lock button to keep it locked in its channel in here. So we're going to put it in without the screw, and then we're going to add the screw through this little hole at a very annoying angle. So you can see how I put it in there, and that captures the button. We're going to do exactly the same thing on the back side. One big spring, then we stick the button in. I said we stick the button in. There we go. And then we hold it down with one finger so we can get at it with an Allen key or screwdriver from an angle in the back. It should move up and down smoothly, snappy. Now we're going to put in the canister lip lock. You need this hardware and these STL files. Okay. So you want to make sure that the lip lock can slide into its channel and move freely. Stick the spring in its back and push the plug down as hard as you can. Make sure that the lip lock can move springily. We'll grab a can. Then use your pliers to pound the plug all of the way home. You can then add a 10mm M3 screw just to keep it all nice and together. Next, we're going to add the roll-on spline plate in the back side of the roll feeder, like that. And we've got this aligned to the blue dot. The square tube is about over here. Oop, right there. Okay, so with the blue dot locked on the back side, the square key should be in that position. That's the key that mates to the lock button on the cassette. Again, I'm going to use two of these skinny metal rods to align things, and three 16mm M3 hex screws to screw the spline roll-on plate to the roll-on knob. Everything should move freely and lock snappily in both positions. Now you can add the indicator knob through the back of the roll feed mechanism, slide the spline over the shaft, and then one more M3 16mm screw and put those guys together. When you're done, it should spin freely. I'm spinning it with the drill here. Okay, now your lid should fit on with the red dot aligned to the red dot, and then you can rotate the knob so it locks in the closed position. The inner spline is designed to interact with the can in an opposite fashion from the outer cams that lock to the body of the roll feeder. In this way, when you lock the lid on the roll feeder, you simultaneously open the inner can, exposing whatever media in the can there is to light, or in this case, to the darkened photoprocessor. See how that works? That's the rotation you do to lock and then unlock the roll feeder, and vice versa for the can. Okay, to load this thing, that little red mark aligns with the lock button on the can in the rolled off position. That's red on the back. The can should click into place beneath the lip lock and into the roll-on spline plate. Spline plate in the back. There we go. Okay, now once your can is locked in position, you can push the lock button on the roll-on mechanism and roll 120 degrees into the rolled-on position. That'll roll the can within the roll feeder into the load position for the photoprocessor. And we'll see loading an actual piece of paper or roll of film later. Here I'm demonstrating but failing to film in a way that I did a good job in light baffling how the inner can opens when the outer feeder closes. Now that we've built all the processor modules, let's look at how they go together. The dryer unit works the same way as the rest of the processor modules, but has a few key differences. First, the cluster is hollowed out to allow for airflow. The tub has two big side ports And then there are these exhaust ports that pop in, and they get each 2 rubber bands flat around their rim and 1 circle of light-proof fabric around that, and then 1 of these retaining rings. I don't use a distribution bar or any plumbing inside of the dryer unit. I do use the tub frame. It's a necessary part of the light baffle and the roller transport system. Take the cluster out, and now you can pop the tubs together. They just pop together kind of like Legos. You need these pieces, 2 tank clips. They're not the same. There's a thin and a thick front and back. There's 1 more 150 millimeter by 2 millimeters 304 stainless steel rod and a transfer roller. The rod goes into the roller and then into the ends of the 2 clips. The square clip goes on the back of the machine towards the tubes, and the round clip goes on the front of the machine near the drive shafts. And those will hold the buckets together and provide a rolling surface for film or paper transferring between one cluster and the next. You want to push them down and seat them against the outside of the clusters, but don't do that until you seat both clusters on either side. Once they're in, you want to make sure that you can wiggle and spin the transfer roller freely. Then push your clips down and together. Connect the drive shafts. Next, we've got a transfer slide. It's got these slide locks that dovetail between the clusters and the slides on either side of the slide. Stick the slide in, slide the slide locks in, and now your 2 clusters are coupled. This is how all of the clusters connect. The slide locks have a dovetail end and a square end. Put the dovetail end in first. All of the common lids have a common light seal on either end. They go together all in one direction like a mechanical human centipede here, just like that. The motor unit and the first cluster go in together, so the first thing you're going to do is detach your first cluster and then slide on the motor coupler. The motor unit's going to have to move like this to clip on to the geometry of the tank. So there's a little wiggle room. Put it in, push it down, and rotate it, and it'll click on. Then reconnect your first cluster. Then you can put on your input lids, your dryer lid, and you're ready. Oh yeah, stick that roll feeder on there. Ta-da! This is the assembly for the 4-inch roll cassette. This is the roll paper cassette. Let's take a look at how it goes together. It has this lock button. Push the lock button in and you can rotate the cassette open. If you're having trouble pushing that lock button down, there's this cassette opening tool. You just align this big bump with this lock button, and then you can open and close the canister. You really don't need this thing. You push this down so it aligns, and then open this guy. With the canister open all the way, you can slide it up until here. You can't slide it all the way out. Right now I'm going to remove the lock button, the spring. Oops, I removed that spring really hard. Now I need to squeeze a little bit on the top, and I can rotate out. Squeeze in, rotate out. Squeeze in, rotate out. And I can pull the top off of the cassette. I can remove the inner spindle. This is actually 2 parts. They're printed with a little bit of support on each part, and they slide together. You put a little bit of glue on this side. On this side, they have a slit for film or paper to slide through. The top of the cassette has these nubbins right there, there. Yeah, there's 4 of them. Each one of those nubbins corresponds to one of these slits. The nubbins slide in the bottoms of these cam slots down here when the cassette is opening and closing. And when it opens like that, the nubbins are sliding up and down these parts of the cam slots. The reason why you have to squeeze and rotate to fully separate the top and bottom is that these slots here and here do not go all the way to the top of the bottom of the cassette, and that's for light sealing geometry reasons. Anyway, to assemble these guys, in a dark bag you would like roll up your paper or whatnot. On here, stick this guy in, add your spring, boop. The lock button has a very subtle square side and rounded side. The rounded side is a nice side for your finger. The square side is brutalist and faces the spring. Then this guy goes in somewhere with this lock bar clockwise of the entrance here when we first squeeze it in, and then I'm going to rotate it back until this lock bar is in its little tiny pocket there. See? Boop. Yep, and once that's rotated like that, the entire canister drops together and then rotates to close like that. You can use pencil or Sharpie to write on these. I would use alcohol to clean off Sharpie, but a wet erase marker. All right, here's the deal, man. We're going to do this once out here in the light before I do it in the dark bag at the studio. This is how to load 35mm film. You're going to want to find this slit and slide the film through emulsion side away from the core, and then fold it once it's through, like that. Fold it, just turn it like that, spool up all the film. Again, in the dark, this is demonstration film for you, dear internet, dear people, humans of the future of Mars in your analog community. Okay, now you take the bottom with your spring and the lock button in there. You're going to put this guy in with the film facing this way, counterclockwise. The top goes in like it did before, clicks back into place, and then slides down. Now you want to close the cassette with just a little bit sticking out like that. Boop. There we go. Now we can open the cassette. Now you want to stick this paper, your leader card, into this slot, not too deep, and you want to have it aligned, not cockeyed up or down, but aligned like that. And then you take a piece of tape, you tape it with film with the emulsion side down, and this wraps all the way to here, between this point here and this point here. Anywhere in this triangle is the correct length for a leader card for processing film in this photoprocessor. Let's go to the darkroom and configure the processor for black and white film. This processor lives in the temporary darkroom before the plumbers get the permanent darkroom up and running, so I can move the machine into a proper darkroom sink. Right now it lives in a boot mat on a countertop. This configuration does not use a pump, but when I had it set up in my shop, I ran a trickle of water to the water rinse modules through their circulation flutes and out through their overflows into the sink around them. I have the machine configured with 6 wet modules and a dryer unit. They're filled with developer, stop, fix, hypo clearing agent, water, and another water rinse, then the dryer. My chems are Ilford multigrade paper developer mixed 1 part concentrate to 4 to 6 parts water, what I call extra spicy and super extra spicy. It gives me a really nice contrasty negative that develops really fast. I use Kodak indicator stop bath mixed as directed. I'm using Ilford rapid fix here, and sometimes I use Kodak. The important part is using rapid fix so I can use just 1 processor unit devoted to fix rather than 2 in a slower process. I use Kodak hypo clearing agent mixed as directed. Each unit takes just under a liter of chemistry, and I like to fill them until the overflow port just starts to trickle a drop. And now it is time to load the processor. To load the processor, push the lock button on the rear of the roll feeder and turn the roll-on knob to align the red dot with the lock button. Take your cassette with the spooled film and leader card from before and insert it with the lock button aligned to the red alignment mark on the roll feeder. Make sure the leader card is free. Put Push the lock button and rotate the roll-on knob slowly to guide the leader card into the input rollers. You can use a pencil to guide the front of the leader card against the guide triangles on the inside of the lid if the leader card edge curls a little bit. Once the roll-on mechanism locks into the process position, align the 2 red dots on the roll feed lid and push it in and rotate the knob to lock the processor. The processor will take up the slack on the roll and the indicator knob will begin to spin. Set your processor speed based on your desired development time. Do some tests of your own with your own film stock and developers of choice. I've been processing with this setup at 84 speed on the motor for Kodak XX and 74 speed for Kentmere at 1:4 concentration of Ilford multigrade paper developer, and it gives me a nice contrasty, snappy look. Okay, you can use an industrial air dryer or Amazon's cheapest hair dryer set to low. It won't melt the PETG that way. I'm demoing this unit in a tray for the gram, but my preferred method is to use a rubber band and a clear garbage bag around the dryer output flange and have it inflate like a protective bubble for cotton candy. Maintenance. You're going to need some gloves, dish soap, running water, and maybe a scruffer sponge. I left this processor for about a month. I had to go out of town and I just left all the chemistry in it. And so it got pretty grody, grew some salt crystals in the hypoclear and the fixer. When I had this in my folding sink in my studio, and eventually when I have it in a permanent darkroom sink at QLab, you can just dump the entire processor all at once and use a hose to wash it out and put all new chems in it. You can take out all the clusters and soak them, or scrub their rollers individually under running water, or in a bucket of soapy water, or both. If things get really, really gross, you can open up all the clusters and dump all of their components into a big soapy 5-gallon bucket. I found that even after a month or two of sitting, even with C41 or RA4 gunk building up, and all of the rollers have always cleaned up just fine with a little bit of scrubbing with a scruffy sponge. They're surprisingly durable and chemistry impervious, if you will. When I set up the processor, I usually like to use a pencil to write on the lid when I set it up, what I set it up with, and what speeds I'm running which film stocks at. It's a good reminder. At home and in the eventual permanent QLab darkroom, I'll run running water into the rinse modules through their circulation flutes and let them overflow and trickle out through their overflow ports directly into the sink. Like this, I change the water in the rinse tanks every couple of rolls. Every day that I'm using the processor, I take a peek under the hoods and make sure that all the chemistry is topped up. And I like to replenish about once a week, and once a month or two, dump the entire thing, scrub it out from scratch, and put in all new chemistry and write a new date on the lid of when the processor was serviced last. The dental elastics that hold the roller pairs together last for a surprisingly long time. I would change them out about once a year if they don't need it, but check the roller tension and springnicity every time that you take the clusters out for cleaning. That should be enough. Here's a bonus part where I make a print in the darkroom. I have had this set up for prints before in my darkroom, just developer, fixer, and then a rinse. I made a bunch of paper negatives that way, and then contact prints, and then a bunch of 4x5 prints from my enlarger at home. I wouldn't go through all the double rinsing and drying and hypoclear just to make some prints, but while I had the processor set up and the darkroom was right there, I made a couple of prints from some of my negatives of Joe. It's really nice to be able to use the same machine to develop some negatives and then just throw a couple of prints in. Hey, big thanks to Joe Van Cleve for helping me test out all of these things as I was working on them over years of secrecy and silence, and helping me figure out how to make this video and helping me film a lot of the latter portion of it. I tried to be really thorough and cover everything so that 100 million years from now, when there's people on Mars and you guys are in your analog photo clubs, you can listen to my ancient TikTok era English and decode it through your Google visors, and it'll be extremely clear how to build this photo processor. For those of you listening right now, go to CAMERADACTYL.com. It's $99. Download it, print it out, and like and subscribe. and download some more stuff. And go have a nice day. Okay, bye.